everyone, very good morning all of you. Welcome to Unacademy. How are you all? Hi. I hope all of you are fine. How are you everyone? Thasin, Priya, Anuradha, Alim, Ammu, Chandrika, Mumtaz, Khatu, Ananthi, Udari, Rishi, Sanwar, Rekha, Rijana, Bhuvi. Very good morning all of you. Kavita. Not yet twisted. Why? Why it is? Okay. So let's start the class. And tell your friend to join live quickly so that we can start the class. And here we are going to do the operating system, total operating system revision. We will do all the important topic of operating system from where always questions are coming. Everything we are going to do here, so definitely you can inform your friends to join the session quickly and so that we can start quickly. Right, so let's start. Here you can see some question is already showing here. And can you comment in this comment section? First of all, whenever we are starting operating system, and operating system is also the subject from where you can expect 10 marks question. It is also the area from where 10 marks questions are coming. Yes, it is possible to get the 10 marks question from here. So can you tell me? Hello, hi Alim. So can you tell me, there are the 4 types of operating system as you can see here. Yes, there are 4 types of operating system. So how they are working? What is that operating system? Real time operating system, single user single tasking operating system, single user multitasking operating system, multi-user multitasking operating system. 4 types of operating system. What do you know about this difference? Anyone can tell me the difference, exact difference between them? Why there are lots of different types of operating systems are there? Tell me. Not possible. So, and do you know that process memory are divided into 4 parts? That is text section, data section, heap and stack. So what are the difference? What are the importance? Why we are dividing it? And another process is synchronization chapter. These are the very important concept like semaphore, critical section, race condition. These are very important concept under process synchronization. After that, when you are coming to the paging concept, the paging and TLB, all that concept, there are the difference are coming like the difference between short term, long term, medium term memory. Demand paging. What is demand paging? What is virtual memory? What is the difference between pager and swapper? Try to recall. Are you able to recall this concept? These are the all concepts are there in operating system. What is logical address? What is physical address? Page table and segment table. What is the difference between paging and segmentation? What is the difference between page table and segment table? Continuous and non-contiguous. Storage allocation. There are 2 types of storage allocation. Contiguous allocation, non-contiguous allocation. So what is that difference? What is the average advantage of overlay, compaction, page table, segment table? Why we are using it? Try to recall and answer me. Are you able to answer or not? And I will help you to recall this concept, because operating system is the area where it is very vast area. Actually, operating system is very vast. There are theoretical knowledge also required. Numerical is also required. Lots of numerical are coming. What are the different types of numerical? CPU scheduling, disk scheduling, page replacement, after that disk structure, paging, deadlock. Lots of concepts are there from where numerical are also coming. So let's start. Here first of all, the difference between the multitasking and multiprocessing. When you are coming to the multitasking, you can see this is performing different types of tasks, but the processor is one. There is only one. See that this is the processes. All the processes they are performing, but only one CPU. One CPU is there. Computer is not different. One CPU means one processor. It is a single computer. In that single computer only one processor are there, but at a time it is able to perform the different tasks. Like you are opening browser, you are opening Excel, you are opening VLC. At a time you are performing multiple tasks. This is called the multitasking operating system. When it is coming to the multiprocessing, what is multiprocessing? The main difference is there. In multiprocessing, here will be the separate CPU register and cache. CPU register cache, CPU register cache. Multiple processing system are there. In one computer only there are multiple CPU, and that's why it is called the multiprocessing. Multiprocessing have two or more than two processor, and CPU added increasing for that. That's why this is the main difference and must remember it. I hope it is clear. So here you can see the difference between the multitasking and multiprocessing. So under multitasking, when you are coming, this is the execution task simultaneously, known as the multitasking, and it is called the multiprocessing. You can take a screenshot also, and I will upload the notes also. As you know, I am uploading every day. I am uploading the notes on Unacademy platform. You can download the notes free of cost. Just go to Unacademy platform, install Unacademy app, register yourself, and then download the PDF from my community. Search Priyanka Chatterjee. You will get the community and you can download the PDF. This is the 5th one going on. Now here is the difference between the single tasking, single user multitasking, multi-user multitasking. So single user single tasking, that is the normal one where only one user is there and single task is going on like MS-DOS. But when single user multitasking means like Microsoft Windows. Microsoft Windows is an example of single user but multitasking. Allow user to perform multiple tasks that we are performing. Single user multitasking is that multi-user multitasking like Unix, Linux. Linux is allowing multiple user also. They are allowing multiple user, permits the several user utilize the programs that are concurrently running in a single network server. It is concurrently running in a single network. That's why it is called the multi-user multitasking operating system. So next section is the text section, data section, heap section and stack section. Why? What is the importance of this section? What we are doing actually in this section? Can you tell me? Write down in the chat box the text section, what is the importance, data section, heap section, what type of work we are doing in this section. Comment me. I am waiting for your comment. Balaji, Lekka, Chandrika, Alim, Rajkumar, Muskan, Bushaira. Anyone? Anyone? Write down in the chat box what you know and let me help you to recall it also. The text section is made up of compiled program code. Whatever is compilation is done. So in that text section we are doing compiled program code and read the form of the non-volatile storage when the program is launched. So it is reading from the non-volatile storage. Read from the non-volatile storage means in secondary memory. Whenever we are writing program, it is storing in secondary memory. But after that we are sending it to the main memory to execute it. For that execution, it's need to send to the text section, and that is the purpose of text section. Data section by data section made up with the global and the static variable. Global variable, static variable, these are allocated for the data section. Initialized prior to executing the main. It will be initialized before execution only. Heap section. This is used for the dynamic memory allocation. Heap section we are using for delete, malloc, free, for this type of allocation. Stack section, why we are using stack section is used for the local variable, because the recursion and all this local variable problem will be solved by stack section. Stack reserve the local variable when they are declared. This is the purpose of the different section. I hope it is clear now. Yes. Now these are the states of the different process. Means when a process is there, it is going through some states. First of all, and this is very important, the states are very important. First of all, this is the new. New means just now the process is created. That is new, right? Next thing is that ready. Ready means the process is waiting for the design. Ready and waiting. Here mostly students are getting confused. Don't be confused between ready and waiting. Text section, compiled program. Yes, very good, very good. You wrote it down. That's good. So ready means I am ready to go to school. So I am ready. I am waiting for the bus. Bus did not came. That is the processor. I did not get the chance for processing. That is called the ready state. Running means your execution is going on. Already CPU is allocated to the process and the execution is going on. That is running. Waiting means some of the part execution is done. Now after that the process is waiting for input output operation. Like bus is waiting for, so the bus is waiting for how? Bus is waiting for like what? Bus is waiting for your friend. Your friend is there, so they need to pick up your friend. That's why the bus is waiting. This is called the waiting state. Terminated means the process has finished. Terminated. Process is terminated means the process completed. So that is called the terminated. Right? So is it clear? Is it clear to everyone? Is this clear? Running, ready, blocked, ready suspended and block suspended. Is this clear to everyone? These steps are very important, and this part is only possible when there is the preemption and no preemption. There are two types of algorithm, preemptive algorithm and non-preemptive algorithm. For the preemptive algorithm, before completion only we have to send it to ready state. Before completion, some of the part may be burst time is maybe 10 millisecond. So in preemption method, what we are doing, after 2 millisecond or something, whenever it is can be according to priority or it can be according to the time quantum, we are preempting that and we are sending it to the ready state again, and again we will give the chance to another process. And this is possible only in the preemptive algorithm, that is ready to running and running to ready. Ready to running every time possible, but running to ready is possible when there is the preemptive algorithm, then only. Otherwise running to block, block to block suspended, then again ready suspended, again ready. This process is very important. Lots of time question came from here. Yes, running to ready, that is possible only in Premature method. Clear? So I will ask you question. Please listen carefully. I will ask you question. Okay? Yes. Now the medium term, short term and long term. All the medium term, short term, long term process. What are the medium term? What is long term? What is short term? Long term means, long term also known as the job scheduler. Long term is job scheduler. Short term is, I already told you, if you came here to learn, then learn. You will get the notes on Unacademy platform. If you don't want to learn, then don't disturb, please. Otherwise, we have to block you. Please don't disturb here. So, CPU scheduler, short term is the CPU scheduler. Medium term is the swapping scheduler. Medium term is used for the swapping. So now see that what is going on. In the long term scheduler, when it is long term scheduler, see that here when I am doing the job scheduling, that is long term. But this is the short term one. From the ready to running, running to ready means it is going on. That is the short term scheduler. That's why here it is the CPU scheduler. Medium term scheduler, you can see here it is doing the medium term scheduler. That is ready to ready suspended and ready suspended to ready. That is the part of the medium term scheduler. Block suspended means process is out of block state. Yes. Block suspended means it was running and because of some reason we block it. Like some problem is going on, so we blocked it. Now after blocking for a long time, this is blocked. That's why it is going to a suspended one. Means sometimes like some people are going for suspended state, like they are suspended from the job, so they are suspended from the job. After that, maybe after some times we are taking it from the block suspended to ready suspended. Okay, it was in the suspended state, now I am taking it. Okay, now we will give the chance again to execute your remaining part. That is called the block suspended to ready suspended, means it is actually unblock. We are unblocking it. Got it, Thasin? Block suspended means the process is out of block state. No, it is more. Block suspended means totally I am sending it to the suspended test. I am totally sending it to the suspended. You are suspended from the job. We will not allow you to do anything. That is the suspended state. Got it? Yes. So these are the main difference between the long term, short term and medium term. This is very important. Tell me what I told. Long term is for what? Short term is for what? And medium term is for what? Write down in the chat box. Then we will go for the next. Long term is, what is the purpose of long term? What is the purpose of short term? And what is the purpose of medium term? Write down in the chat box. Write down. Then we will go for the next concept. What is context switch? Yes, long term is job scheduler. Then medium term and short term. What about medium term? Okay, now everyone is writing. It's good. Yes. Now we will go for the context. What is the context switching? What is the meaning of context switching? Context switching means that CPU is allocated one process. Here is the CPU. So P1 came to here. P1 is here. So P1 is executing. After that, I am removing P1 and I am giving chance to P2. So this is called the context switch. P1 to P2, then P2 to P3. This is called the context switch. Okay. So the method to store and restore the state or the CPU in PCB so that the process execution can be resumed for some point and later it will come again. This is called the context switching. Okay, context switching method is important for multitasking because we are taking care of each and every process, but for 2 second, 2 second, 2 second I am giving chance, again I am sending it to the ready state, again I am giving chance to another one, so that everyone will be happy. Okay, I am attending everyone, but I am not completing everyone. I am attending everyone for at a time, but I am not completing. This is the task of multitasking. Now here under there are different types. It's a CPU scheduling algorithm. What you know about CPU scheduling algorithm? There are two parts. One are the preemptive CPU scheduling, another are the non-preemptive. Right. So under preemptive what are coming? Under non-preemptive what are coming? What are the preemptive CPU scheduling algorithm? And what are the non-preemptive CPU scheduling algorithm? Preemptive and non-preemptive. Write down in the comment section. I am coming with water. Yes, preemptive, round robin, SRTF. Priority scheduling is also preemptive. Priority also preemptive. Priority scheduling is also there. Non-preemptive, SCF, CFS, SJF, SHF, not SJF. SJF, LJF, these are the non-preemptive one. Yes. So when we are coming, these are very important last minute revision notes. Starvation. Which one is suffering from starvation? STF, LTF, priority based algorithm. STF means shortest time first, shortest remaining time first. These are the both are the preemptive algorithm, non-preemptive algorithm. So non-preemptive algorithm is always suffering from the starvation because the shortest one or the longest one I am giving priority. Opposite one is not getting chance. Priority based also the starvation. Starvation means it is waiting for a long time but it's not getting chance. Right. Next one is no starvation. In round robin there is no starvation because round robin how it is working? Round robin every time for per millisecond we are setting a time quantum. Whenever the time quantum is over, then I am getting chance, giving chance to another one. This is called the no starvation in round robin. Convoy effect is FCFS. FCFS, why convoy effect? Convoy effect is that first come first serve. So first one came, that is a very lengthy one, long one. Another one is waiting, that is a very small one, it is not getting chance. This is called the convoy effect. Like a minister came and that's why you are waiting for a long time, you are not getting chance. It is like a minister convoy. This is the convoy effect, and convoy effect is there in FCFS. Right. Most suitable algorithm for the real-time system, that is the preemptive priority scheduling. Most suitable algorithm for the time sharing system, that is round robin. Minimum average response time required in SJF, because SJF we are taking the shortest one, so response times will be quick. Minimum average response time required for the primitive version, that is the shortest remaining time first. This is your quick revision for theoretical concept of CPU scheduling, and I think it's done. Right. Now do this question. So we did some of the concept. Now you can do the question. Now you can do the question. Yes, answers are coming. Yes, option C is the correct answer. Very good, all of you. Very good, because it is not the B is the not correct. Multiple computer are not there. You all of you are correct. Yes. Now do this one. A process residing in main memory and ready and waiting for execution is kept on. In which queue? Which queue we should kept this one? Answer everyone. Yes, all of you are answering. That is ready queue. All of you are correct. Ready queue. Don't be confused with waiting queue, because it is waiting for execution means it did not get the chance for CPU. That is the ready queue only. Waiting for input output, that will be the waiting queue. Next one. Do this one. Identify the circumstances under which primitive CPU scheduling is used. Poll here, poll is not there. In YouTube, poll you will not get. Udari, poll we will get in Unacademy platform, because here in YouTube I cannot start the poll. That is really, we are missing the poll, right? Poll will come from the next week. Also there will be the revision. After that we will go back to Unacademy platform for the live quiz, and there will be the poll. So everyone, you can enjoy the poll feature on Unacademy platform. That's why definitely install Unacademy app and try to follow me on Unacademy platform, so that you can enjoy the live quiz with my class 10:30 am only. Yes, all of you are giving answer A is the correct answer. That is correct. From the primitive one, the process switching from running to ready, that is the special feature of the primitive one. And the process waiting to ready is going on everywhere. That is everywhere, not only primitive or non-primitive, both it can be going on. But here the process completes its execution. No, before completion only we are printing it. And the processor switches from ready to waiting. No, ready to running is going on. Ready to waiting is not correct. So answer will be this one. Now we will go for the process synchronization, semaphore and all. These are the some key points to remember under process synchronization. What is called cooperating process? Cooperating process means it is the process that can affect or be affected by other process executing in the system. By other process it can be affected, that is called the cooperative process. Means both are working cooperatively. Independent process means there is no dependency. I am working independently, you are also working independently. No dependency between them. What is race condition? Race condition is very important concept. The several processes are working in a same data. When they are working in same data at the same time, then the execution depends on the particular order. If we are changing the order, then result will be also changed. If I am executing P1 after that P2, then I am getting a different result. If I am executing P2 then P1, then I am getting a different result. This is called a race condition, right? Critical section. What is critical section? Critical section is the segment of the code where at a time only one can execute. That is the critical section. It is the common area which one is used by everyone, but at a time only one process can do it. At a time only one process can change the common variable or update and so on. This is called the critical section. What is semaphore? Semaphore, we are using semaphore is the special type of variable which deals with the critical section. Through the semaphore only we can handle the critical section, that if one already go to the critical section, then I will not allow anyone. And in the semaphore there are two operations. One is called wait, another is called signal. Wait and signal. Whenever any process is interested to go, I want to execute, then it will call the wait. And if the semaphore value is greater than 0, if semaphore value is greater than 0, then only it will get the chance. If the semaphore value is less or equals to 0, then it will not get the chance. And always wait will do minus minus, semaphore minus minus. Signal will do the semaphore plus plus. Signal means my work is done, I am coming out. That is called the signal, right? So it is the entry section, critical section, then exit section. In that way this is going on. That is called the work, means how we will work in the critical section. What is mutual exclusion? The requirement there are the critical section. First we have to satisfy mutual exclusion, progress and bounded waiting. So what is mutual exclusion? Mutual exclusion means if I am working, then another one cannot come. That is called the mutual exclusion. No other process cannot come to the critical section. Always we will maintain it. Progress means if one process is not interested, then other process should get the chance. I am not interested to do. It's not like that if I am going, then only another one can go. If P1 do it, then only P2 will get the chance, otherwise not. It should not be no dependency. Maybe P1 is not interested, so P2 is interested to go, so P2 can go here. That is the progress. Bounded waiting means I give the chance to P1. Now P1 is working. P1 is not giving chance to anyone. It's not possible. We should fix a time whenever any process is getting chance for critical section. After a bounded waiting time means maybe after 5 seconds you have to leave, so that another one can get the chance. This is called bounded waiting, and these are the very important three concepts of operating system: mutual exclusion, progress and bounded waiting. Is this clear? Yes. Next thing is the inter-process communication. We are doing all concept, all theory, so that your all revision will be done. So what are the main focus? What are the 3 points? What are the three main key point? Just now what we discuss? Write down in the comment section. Write down. Write down in the comment section. Just now we told for the critical section problem what are the main 3 things we have to consider and we have to satisfy it. What are those? Mutual exclusion and progress, bounded waiting. Yes. Now in inter-process communication are two types. Inter-process communication are two types. One is process are two types. One is independent process, another is cooperating process. For independent process, no problem are there. For independent process, there is no problem. For the cooperating process, when it is a cooperating process, for the cooperating process, there are two ways. The process communication can be done in two ways. One is called the shared memory, another is message passing. Shared memory and message passing are the two way. Here shared memory means common memory P1 is also using, P2 is also using. It is called the shared memory. They are just using that memory location. They are not executing in same location. Here sometimes students are doing mistake if they are executing in same location. No. P1, P2 executing in different location. But the shared memory they are using to maybe to store the data or access the data. That is the shared memory. Execution is going on in different memory only. Don't do the mistake. Next one is the message passing. Message passing means they are executing separately, but some of the message I want to give you to anyone, so I will write it in the message board. It is just like that. It is a notice board or message board. Whatever message I will write there, anyone can read it. Whatever message I want to P2 want to do, they also write it. It is a common message queue where both can send the message. This is called the message passing process. They are using the same message queue. Clear? Yes. So here is the classical definition of wait and signal. You can see this is wait and this is signal. In wait we are doing S minus minus and signal we are doing S plus plus. Wait means S minus minus, signal means S plus plus. This is very important. Questions are coming from here. And there are two types of semaphore. One is counting semaphore, another is binary semaphore. Counting semaphore means here multiple number of resource we can handle. Maybe there are 10 printer. So I will set the semaphore value equals to 10. At a time I can allow 10 processes to get the resource. Binary means only one resource I have, either 0 or 1. At a time I can give it to only one. That is called the means binary semaphore, and this is the counting semaphore. So now here you can see what is bounded buffer problem, dining philosopher problem and the reader writer problem. These are the some classical problem of the semaphore. You have to remember this classical problem. I am not going to the detail. Now do this question of semaphore. Now do the question of semaphore. Do it. Answer. Yes, answers are coming. Answer will be 0. Those who are telling yes, answer will be 0. 1 is the answer. P2 access. So here the semaphore, it is initial value of the semaphore was here 1. P2 needs the access means it will call the wait. Wait means minus minus. So it will do the 0. After that again it will call wait. It will be the minus 1. Then again it will call wait. It will be now minus 2. Exit from critical section means signal. Signal means plus plus. So it will do minus 2 plus 1 means minus 1. Now again exit from critical section, that is plus plus minus 1 plus 1 means that is 0. So final value will be 0 here. 0 Udari, it's not 3, 0 0. In that way, wait, I am doing wait. So I will go to minus and after that the signal means plus. So answer will be 0 here. Now do this one. Which of the following inter-process model used to exchange the message among the cooperative process? Yes, answer will be C. Just now we have discussed shared memory and message passing for the cooperative process. Very good. Now do this one. Answer. What will be the answer for this? Suppose P, Q and R are cooperating process, satisfy the mutual exclusion condition. Then if process Q is executing into the critical section, then yes, then neither P nor Q will get the chance, because mutual exclusion is always telling if anyone is there, then other one cannot come. Yes. Now we will go for the demand paging, virtual memory, process, pager and all. So what is virtual memory? Virtual memory is a technique that allows the execution of the process that are not completely in the memory. How it is possible? That is, maybe my main memory size is 20 MB. My main memory size is 20 MB. But my process size is maybe 25 MB. So can I execute it normally? Normally I cannot execute, because total process will not get the chance here. What I can do, I can divide it into some pages. At a time I will take some pages here, I will execute it. After that I will replace some pages. Then after that I will take the remaining pages. In that way we can execute a process also which is bigger than the original main memory, right? Completely, that is called the virtual memory. So enable user to run that are larger than the actual physical memory. Virtual memory makes the task for the programming much easier. Virtual memory allow the process for sharing file and all. This is the main concept of virtual memory. Next one is, what is demand paging? Demand paging is just now what I told, that in the out of all the 25 pages are there, out of 25 pages I take maybe 10 pages at a time here. Now CPU will ask for the page. CPU is executing one function. Maybe CPU is asking that now I need page number 20. As per the requirement, I will go here and I will take the page number 20. This is called the demand paging. On demand of CPU, we are loading it to the main memory. That is called the demand paging. Demand paging is the method of virtual memory management that loads the page when they are demand during the program of execution. So here why? Less swapping time will be there, less input output will be needed, an amount of physical memory, less amount of physical memory will be also needed, more useful and faster response time. That's why the demand paging are used. Right. Now the next one, the difference between pager and swapper. Actually pager page swaps the pages into the memory when page will be needed into the memory, and swapper is swaps the entire process into the memory. That is the difference, that there is the process, out of this process I am taking some of the pages into the main memory. But swapper means this main memory is allocated P1, total process is here. After that, next time I will allocate total process P2. That is the difference between pager and swapper. It is working on only paging, and this is swapping, means the total process. Just now we did the swapping, right? P1, then after that I will go to P2, then P3. That is called the swapper. This is the task of the swapper. It is working on demand paging, and this is used on normal paging system. This is the difference between pager and swapper. Logical address and physical address. This is very important, where students are mostly getting confused. Logical address are given by CPU. When CPU is asking for that, it will ask for the page number and offset. CPU send that page number and offset. That is actually the number of secondary memory, because the process are divided into some pages. CPU know that. But in physical memory, means main memory, there are some frames. These are the some frames here. CPU don't know that. So after getting the request, it is going to the page table. From the page table we are getting the frame number. After that I am going to here, and then I am sending it to the CPU. So page number and offset, this is actually called the logical address, and when it is the I am getting the frame number and offset, this is called the physical address. That is the difference between logical address and physical address. Clear? Clear? Is it clear? Is it clear? In the address generated by CPU is the address actually seen by the memory hardware. That is the physical address. So logical address is page number plus offset. Offset means that is the size of the page, and physical address means the frame number and offset. Right? Got it? Clear? क्या बताओ यार. हाँ. Quite clear now? Good. Good, very good. Physical address and logical address. What should I say? I don't know. Page table and segment table. So page table is here and segment table is here. So guys, you can understand how much disturbance we have to take the class. So it is a request to everyone that try to share with that friends, those who wants to learn, really those who wants to learn. So you can send them the link so that they can learn and they can get the benefit. Okay. Yes. Physical. Yes. Physical means yes. Like that you can remember. Yes. Now see that. Page table and segment table. Page table is the paging technique. Segment table is the segmentation technique. Because page table means we are dividing into the some fixed pages. There are some fixed pages and we are working on that only. Like we are fixing the page size like 2 byte. Maybe my page size is 2 byte, right? So maybe my page size is 2 bytes. So I will store all the pages here in the page table. But segment table is that segment table is working on the base address plus the size of the segment, because segment is not a fixed. Segment is depending on, segment is not the fixed one. Segment is depending on like that कि maybe function 1 requires 10 line. So 10 line means it will be 10 byte. So I will allocate 10 byte space for the segment 1. Another one required maybe 20 byte. So I will allocate 20 byte for the segment 2. It is depending on as per the segment. Total segment I am taking into the table. Total segment I am sending it, so that there will be no fault. Whenever one function is executing, it will be executed totally. That is the difference between page table and segment table. That's why here segment base and the segment limit will be there. Just wait 1 minute. Some important call is coming. Wait 1 minute. Hello? 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 Yes, sorry for the disturbance. I think it was also a disturbance. No one is talking. Okay, so segment limit. Now here is a contiguous and non-contiguous. So what is the difference between contiguous and non-contiguous? Contiguous means just like the array, one by one we are accessing. It is the contiguous location. Non-contiguous means it is just like a linked list. Here I hope it will be here, another one will be here, that is linked list. I will start from 2000 location, it will be 2001, then 2002 and so on. But it can be 2000, it can be 1000, it can be 5000, anything is possible. That is called non-contiguous, right? So these are the some technique. Overlay we are using for the program size larger than the amount. Compaction, it is the solution of the external fragmentation. That is the solution. Solve the problem of segmentation, fragmentation. Page table, segment table already we discussed. Now some numerical we can do. Time is also going to end, so do the numerical. Do this. Overlay actually used for the fuzzy system. Overlay is using in like washing machine and all that. So overlay not that much important, not that much required. Do this. It is also just like a virtual memory concept only. What will be the answer for this? Yes, answer is coming. So here the bus time is given and arrival time given to you. We have to do round robin. Round robin is the very important one from where always question are coming. Round robin. How it will work, how the round robin is working. For round robin we have to maintain two queue. One is the ready queue and another is the NAT chart. Right. So as per the arrival time 0, as per that who is coming first, only P1 will came first. So it's okay, P1 will came first. I am doing here, that will be better. P1 will came first. After that, so now I am making the NAT chart here, that at the time 0 P1 came. Here the time quantum is 2 milliseconds. So P1 will execute 2 milliseconds. After that here 1 will be the remaining. Now at that time when P1 is leaving, at that time who arrived? At that time only P2 arrived. That's why we have to write P2. After that P1 not completed. So that's why again I have to repeat P1. So now anyone did not arrive. So no need to think about that. P2 came here. P2 will execute till 4. Now here it's remaining 2. Now when P2 is coming out, then is there anyone who arrived? No, because P3 arrived at 5. So no one arrived. So I will repeat here P2 again. Now P1 will come. So P1 is coming from here. Now P1 remaining only 1. I will execute till 5 and it's done now. It is 0 now. It's completed its task. Now at that time P3 arrived. That's why now I can write P3. I can write P3 now. Now P2. Here was P2. So I will take P2 here. After that P2 was remaining 2. So it will be till 7. Till 7. Right. After that it will be completed its task. It is now 0. Now after that last one is P3. All are done. Last one is P3. That's why P3 will come here. And P3 will be till 12. Because it is only 5. So P3 will be till 12. Right. So now your arrival time is done. So it is correct NAT chart. As per the NAT chart, this will be the NAT chart. Now we have to do the completion time, turnaround time and the waiting time, because it is asking you turnaround time and waiting time. So completion time of P3 is 12 here. P2 is 7. P2 completed at 7. P1 completed at 5. Turnaround time is, what is turnaround time? Turnaround time means completion time minus arrival time. So completion time is 5, arrival time is 0. 5, 7 minus 2, 5 and 12 minus 2, that is 7. Right? Yes. Now next one is waiting time. Waiting time means turnaround time minus burst time. That is waiting time. So turnaround time is 5. Burst time was 3. Waiting time is 2. Turnaround time is 5. Burst time was 4. That is 1. Turnaround time 7. Burst time is 5. So that will be 2. So now you can calculate it. It will be 17 and this is 5. Total number of process are 3. So average turnaround time will be 17 by 3 and average waiting time will be 5 by 3. So you will get the answer. It will be 5.66 and 1.66. Clear? This is the way how to solve the round robin algorithm. This is very important algorithm. I hope it is very clear and must practice the round robin algorithm. Yes, 5 by 3 and 17 by 3. So here it is the primitive job. Do this. Here consider the three process. CPU burst time is this one. Arrival time, burst time is this. Now do it. Do the answer. Okay, answer is coming. Yes, answer is 2 only. You are correct. So here it is asking about that the scheduling primitive shortest job. In shortest job scheduling, don't do mistake with that. This is the shortest one, so that's why I will take P2. That will be wrong. Because always we have to think about the arrival time. Who arrived at the time 0? Only P1 arrived. That's why P1 will get the chance. So P1 will get the chance and P1 will execute till 1 because it is the primitive one. Primitive means every millisecond it will check. So as it is primitive, it will be till 1. After that, here it will be remaining 7. Now P2 will get the chance. P2 arrived now and P2 is 4. So P2 will complete its task because other are all greater than P2. So P2 will be till 5. After that P3 and P1. Out of P1 and P3, P1 is the smallest one. So that's why P1 will get the chance. It will be till 12. And finally P3 will get the chance and it will be till 21. And now you can solve it and you will get the answer in same way. I hope it's clear to everyone. Right? Now if your NAT chart is correct, then after that you can do the other also. So do this one. How many context switches are there? How many context switches are there? Do it. The numerical are very important in operating system. You can think like that, maybe 60-40. 60% is numerical, 40% is theory, like this way also can be question asked. And here you can get a 10 marks question. That is very important. Okay, yes, all of you are correct. Only 2 because here 10, 20, 30. 1 by 1 only will be done. So first of all P1 will get, then P2, then P3. Because there is all are greater, although it's primitive. So only 2 context switches will be done. This is the same type of question. You can do it. It is a home task for you. Round robin. This is also SJF. This is also a home task for you. This is also a home task for you. All the programming question. So do this one. It is the disk scheduling. Disk scheduling algorithm is also very important. Do this. What will be the answer? Shortest sick time fast. I need answer from everyone. Only some people are answering, others are not answering. Yes. Now I am getting answer. Shortest sick time fast. First of all, write it down in ascending order. This is the best way of doing. Write down in ascending order, then start from the location and check it which one is closer to me. Shortest sick means which one is closer to me. That's why writing in ascending order is the best way. So if you are write down it, after that you can see from 20 it will go to 22, then it will 10, 6, 0, then 38, then 40. After that, for calculation also will be take the last one. Take the extreme left or extreme right. So here 22 minus 20, then 22 minus 0, then 40 minus 2. So your answer will be this one. And after that, here was the sick time. Each and every time, this is the 2 millisecond. It was given that 2 millisecond move from one cylinder to another cylinder. So that's why I have to multiply with 2, because it is the total distance I have to cover. Now each and every distance covering is taking 1 unit, is taking 2 millisecond. So that's why it will be 120 millisecond. Do this one. This is a very good question of page replacement. Do this one. Actually, this question will be, you have to solve every one. So maybe I can give it for home task for you, because here it is you need to solve FIFO, LIFO, LRU optimal. Then dash page replacement algorithm has minimum number of page fault, because you have to solve every one. FIFO also, LIFO also, LRU also, optimal also. From this one your concept will be very clear and your practice will be done. Must practice it, the all page replacement algorithm, and after that you will get the answer optimal. 4 will be the correct answer. Now do this one. This one is the conceptual question. Do it. This is we will do in the class. FIFO is not the correct. Optimal is the correct one for the previous. Do this one. Do it correctly after the class. You can do it that correctly. Practice it all so that your concept will be clear. But this one, do it now. This one must do it now. Here this is given 1, 2, 4, 5, 2, 1, 2 and 4. Answer, what will be the answer? Number of page fault. Okay, answers are coming. Mumtaz is telling 1. Option 1. Option 3. Option 1 is the correct answer, because here 1 and 2 in the order 1, 2, first and second, these are already there. Means before starting only, here this is 1 and 2 is already present. You have to consider that also. 1 and 2 is already present. That's why this 1 will be hit, this 2 will be also hit. This both are hit here. This is not the miss. Normally when you are starting from this position, it will be the miss. This 1 and 2 is already there, that's why it will be the hit. And here only you are doing mistake. If you are doing mistake here, then do the correction. It is already hit and answer will be this one. That's why. Okay, answer is not 3. After that you can do. Here only you are doing mistake. It will be the hit. Got it? Yes. So now here already we did this one. This one also did. Do this one. Dirty bit is used for what? And we have to end the session. It's already 1 hour over. Yes, dirty bit is used for page modified after the load into the cache. That is the purpose of dirty bit. So it is a question of TLB. Do this one. TLB is also very important. What will be the answer for TLB? TLB, numerical. That is also the next important numerical. TLB, must do it. Must do it. Yes, so here TLB formula is like this way. That is, when there is hit ratio, it will be TLB access time plus main memory access time. Then 1 minus hit ratio, that is miss ratio, TLB access time plus 2 into main memory access time. So your answer will be 195, and this is the answer. Now this is the last question. The last question is for deadlock. Deadlock is the next important area from where questions are coming, and with the deadlock only I will end the session. So do this question. The maximum value of n which never enter into the deadlock. What will be the value? Yes, answers are coming. 3 is the correct answer, because here what we have to do, there are 12 instances. So number of resources are 12. Now n processes are there. Each process required 4 instances. So maximum need is 4. We have to do the worst case. Worst case is maximum need minus 1. That is 4 minus 1 is 3. If I am giving this 3 resources to everyone, then after that also one resource have to be there. So that is my target. If I am giving it to the 4 processes, then it will be 12. I cannot do it. because only 12 resources in my hand. If I am giving it to the 3, then it is 9, remaining 3 will be in my hand, so it will be not a deadlock. So that's why answer will be 3. Always deadlock question solving is very easy by doing this method. Worst case is maximum need minus 1. So it is also a same type of question on deadlock. Must do it. This is a home task for you. And Acha, do this. Which one is the safe state? I am trying to end, but still I am not able to end. Because I want to teach you everything. All the topic I want to cover. So that's why always I am extending the class. They are allocating me 1 hour and I am taking more and more. That is always going on. Not only here in paid class, also that is going on every day. Right? Do it. Do this one. Which one is the safe state? The maximum need, current allocation given. Now according to the current allocation, is it safe? If it is safe, then what will be the sequence? Yes, answer is 3 only. How to do it? Because here we have to do the future need. Future need is the maximum need minus current allocation, that is 5. Here it will be 5 also. 9 minus 4. Here this is 3 and here it will be 2. This is my future need. Now it is given that the 4 processes, 12 instances are there. And according to the current allocation, how much? 3 plus 4 is 7, 9, then 1, that is 10. Already 10 allocated. Total 12 was there. 12 minus 10, 2 is available to me. So with this availability, I can handle only this one. So that's why I will execute P4. When I am executing P4, previously there was 2. Plus P4 will leave that current allocation, that is 1. Now 3 is in my hand. Now I can execute this P1. So I can execute this P1. After executing P1, I cannot execute P1. I have to take that future request. So future request is after 1. Here it was the future request. So future request is 3 here. This is the 3. So I can execute P3 here. When I am executing P3, then P3 will release mode 2. So now I have 5. Now I can execute any one of them. So first one is P4, after that P3, that is confirmed. So P4, P3, this is only the answer. So it will be the answer. So this is not possible. This is also not possible. After that any one of them, that is yes, P1 I can release. When I am doing P1, then it will release more 3. Now availability will be 8. And after that definitely I can execute P2 also. And it is the safe state. This is the way how you have to find out that a state is in safe or not. So you are also now safe. Because so many questions, so many concepts we did in operating system, these are the very important area. Must cover this area, and I will upload the PDF on Unacademy platform. Go to my profile. You can visit my profile. And this is the new batch already started. Paper 1, paper 2. PYQS is going on. Here you can definitely go through the batch. Here we are covering everything. You can definitely go through it. Already yes, already this is going on, and you can go to my profile. In my profile also you can visit it, and there are free classes, lots of free classes. You can see here it's already gone. Some problem is there, no problem. So use my referral code Priyanka C Live to take your subscription. If you want to do the PYQs with me, complete PYQs, crash course, all are going on. You can take your subscription using my referral code Priyanka C Live. You will get 10% off here, and with the same referral code you can, yes, for paper 1 in that batch course you can do it. Paper 2 I will cover, paper 1 Shiva sir will cover. In that batch course you can do paper 1, paper 2 both. That is the batch course. That's why you can take the subscription, and using this subscription you will get the 10% off here. Okay. So bye everyone. 1 month subscription is also available. You can take 1 month also if you want. Bye. Bye everyone. See you again Monday. Saturday, Sunday no class. I will see you again Monday. Do your own revision, attempt mock test. Chalo, bye.